solving equations of the form a sine x plus b cos x equals c, where a, b and c are constants. Are constants not equal to 0. Okay, so if you've got something like sine x plus 3 cos x equals 2, this is a c, by the way. That's not a 0, it's a c. So when you want to solve equations of that form, a sine x plus b cos x equals a number, not equals 0. If it's equal to 0, you just take the b cos x to the other side, or you divide through by cos x. Whenever you've got sine x equals cos x, you can just divide through by cos x, okay? But whenever you've got a sine x plus b cos x equals some constant, you have to use one of two methods. So use either the auxiliary angle method or T formula, or T formulas method to solve. Okay, so we're going to revise using those methods. So you have to recognise when to use the methods. That's the question that we're going to do. When you use the auxiliary angle method, so I want to do questions of this type. So this is the type of question that we will do. Now for the auxiliary angle method, there are 4 ways that it can be written. So if you're given the sine term first, and you could just rewrite that to make sine first if you want. But if it's of the form a sine theta plus b cos theta, if it's like that equals to some number, you often put it in this format. But the question, it will tell you. The question in the HSC should tell you, rewrite that or whatever in this form. It will tell you. So there are 4 ways that you could be asked to rewrite the left-hand side. You could be asked to put something sine theta plus something cos theta in this form. Notice, sine is first, keep the sign the same. Do you know what I'm saying? Sine is first, it's a plus. Or you could be asked to do a sine theta minus b cos theta, put it into this form. Sine, keep the sign the same. Okay? Or you could be given something like this, a cos theta plus b sine theta. For cos, we always change the sign. So you will be asked to do one of these 4 things. Or you'll be asked a cos theta minus b sine theta, asked to put it in this format. I think, yeah. So I don't want you to learn the formulas that you've been given in the book, that tan theta is whatever, whatever, and all this sort of stuff. Because often the HSC will say to you, express cos x plus root 3 sine x in the form, do you know which form they're going to ask you to do it in? R cos theta minus alpha, R cos theta minus alpha. Then it will say, hence solve this equation. Cos x plus root 3 sine x equals 2 for 0 less than or equal to x less than or equal to 2 pi. That's how they will ask you the question. Okay? So let's do that. So auxiliary angle method, you can box these up. They're the 4. You don't learn them. They'll give them to you. They'll give one of them to you. The question will be like that. Okay? So we're going to solve that one particular question both ways. All right? I think we'll do a cos one and then we'll do a sine one. And we're going to do T formula as well. All right? So let's start. Okay, so I've got cos x plus root 3 sine x equals r cos theta minus alpha. What do? Do you remember? You expand the right-hand side and you get r cos theta cos alpha plus or minus. Sine is keep the sign the same. Plus, now instead of putting bracket here, I'll just put the r again. Is that okay? I could go r bracket, but you know, each term plus r sine theta sine alpha. See, notice that why is the plus cos question with the minus? Because when you expand the minus one, you get the plus and you change the sign. So now they're identical. What I like to do next, and what have I done? Just one sec, girls. Can I just fix and put x here? Can we just fix that? Either they're going to put theta here, or do you want to change these to theta? Change these to theta, 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 sorry, theta, theta, theta. They're not going to put x and theta. All right, so they're all thetas. No x's, please. So now, do you know what I do? I equate, but sometimes I rearrange. See how the cos thetas are the same? All right, so you can rewrite these opposite ways around. Sometimes I go like this, equals r cos alpha cos theta plus r sine alpha sine theta. That way I know that r cos alpha is what? 1, because the cos thetas are the same. So therefore we can say that r cos alpha equals 1. And see how I've got the sine theta here and the sine theta there? What does the r sine alpha equal? And r sine alpha equals root 3. So then you just rearrange those. Therefore, cos of alpha is 1 on r. Sine of alpha is root 3 over r. What do you do next? Do you remember? Right angle triangle, alpha. Do you remember? Label the sides. Cos is adjacent over hypotenuse. Sine of alpha, and you work in the one triangle, is root 3 on r. So now we can work out what r is. R is the hypotenuse, which is Pythagoras' theorem. Square root of, do you remember? 1 squared plus root 3 squared, which is the square root of 4, which is 2. And tan theta alpha. Tan alpha is root 3 on 1, which is root 3. Therefore, alpha is 60 degrees, but we don't write 60 anymore. We write pi on 3. That's the only difference. So you did this all last year. I think 90% of the HSC questions are in radians now. They're not in degrees, all right, if we look at past HSCs for this topic. So what you did last year was trig ratios, even though you had trig equations in it, but they worked in degrees. In the HSC, they work in radians, in the HSC topics. So therefore, I can now say that cos of theta plus root 3 sine theta equals r is 2. It's equal to 2 cos theta minus pi on 3. And now we can solve our equation. So now the question is solve cos theta plus root 3 sine theta equals 2. Notice it's of that format, something sine theta plus something cos theta equals a constant. So you have to use auxiliary angle method or T formula. Well, we've just rearranged cos theta plus root 3 sine theta to be 2 cos theta minus pi on 3 now equals 2. So instead of solving this, we actually solve this because this has been rewritten to that. Now it's something we can solve. So how do we solve this? What do I do with the 2? Divide by 2 and you get cos theta minus pi on 3 equals 1. Now, look, I know some of you will be tempted to expand. But I don't know why you'd do that, because I think you're going to end up, you would never do that. You'd end up with cos and sine. I think if you expand that, you're going to end up with what you started with. If you do the double, not the double angle, but the sums and differences. When you're asked to solve that, we do what we were doing yesterday, which is change the domain and all that sort of stuff. Do you remember? So now we're solving that from 0 to 2 pi. So I go like this, 0 less than or equal to theta less than or equal to 2 pi. What's my new domain? Theta minus pi on 3. So take away pi on 3 from each of those. Basically, we're taking away a third. So we're going from minus pi on 3 through to 2 minus a third, 1 and 2/3, 5 pi over 3. But really, this is not, don't work out the acute angle for me. This is cos something is 1. How do you solve that type? You draw it. So cos curve looks like this, but you've got to go to minus. I'm going to do some negative ones as well, because we're actually not going all the way to 2 pi. 2 pi's here. You're supposed to stop somewhere here. That's 3 pi on 2. That's pi. That's pi on 2. That's negative pi on 2. You're supposed to stop about from, we're actually going roughly from about here to there. Do you get that? We're going from minus pi on 3, which is minus a third pi, which is not as far as minus pi on 2. Do you get that? All the way up to there. Now tell me what the solution for where does this equal 1? What's your, well, there's a 1 up there, but that's outside. Where does this equal 1? Only in one spot. So therefore we have to go theta minus pi on 3 is 0. Where's the question? Therefore, what's theta? Pi on 3. So let's do the same question with t formula. So we're going to solve cos theta plus root 3 sine theta equals 2. Obviously, t formulas might be a little bit easier, but anyway, let's start. So cos theta, you do have the t formulas on your formula sheet. Here they are. But be careful, because with t formula, t is tan theta on 2. So these little t's are tan theta on 2. So what do? We replace cos theta with
1
minus. So we're solving this from 0 to, actually, to 2 pi. So let's go. 1 minus t squared over 1 plus t squared plus root 3 times 2t over 1 plus t squared equals 2. All good? So you're replacing the sine theta and the cos theta both with their t formula expressions. Denominator's all the same. You can multiply through by 1 plus t squared. So multiplying each expression by 1 plus t squared will eliminate the denominator. You'll get 1 minus t squared plus, this is root 3 times 2t, which is what? What happens when you multiply root 3 by 2? 2 root 3t equals 2 what? 2 bracket 1 plus t squared, or 2 plus 2t squared. So now let's expand. 1 minus t squared plus 2 root 3t equals 2 plus 2t squared. Where are we going to go? Left or right? What do you reckon?
Right.
Let's go to the right so that the t squareds are positive, taking everything over. I've got 2 plus 2t squared minus 1 plus t squared minus 2 root 3t equals 0. So I've basically put it all over to the right, but it's okay that I put my equal 0 here. Alright, so now let's put the t squared terms together. What have we got? 3t squareds minus 2 root 3t plus 1 equals 0. Geez, I could not factorise that. So we're going to use quadratic formula. T equals negative b, which is 2 root 3 plus or minus the square root of 2 root 3 squared. What do you think that is? You square the 2, you get 4. Square the root 3, you get 3. 4 times 3 is 12. You can go over here. 2 root 3 squared is 4 times 3, you know. 4 times 3, which is 12. So it's b squared minus 4 times a times c over 2 times a. So 12 minus, square root of 12 minus 4 times 3 times 1 over 2 times 3. Why do you think I got, what am I getting under the square root sign? And why do you think that is? Based on the fact that we've just done the question. It's only got one root. You're only going to have one answer. So it's 2 root 3 plus or minus 0. Of course, I didn't even need that, but that's okay. What have I got there? What's that? Root 3 on and 3. And tell me what that is. No. That's 1 on root 3. Do you know why that's 1 on root 3? Because 3 is root 3 squared. Do you get that? What is 3? Isn't it square root of 3 times square root of 3? So basically one of the square root of 3's on the numerator cancel with the, watch, root 3 times root 3 squared. Well, I have actually made it like this. Do you get that? Now, T is not tan theta. T is tan theta on 2 equals, only one answer there. Right, but you're probably thinking, but miss, tan theta on 2 is positive in quadrants 1 and 3. You should be getting 2 answers. But we're not going to get 2 answers because we are not solving tan theta is 1 on root 3. We're solving tan theta on 2 is 1 on root 3. Yes, I know it's quadrants 1 and 3, but you need to change your domain. So our question is 0 less than or equal to theta less than or equal to 2 pi, but I don't have 2 pi. I don't have theta. I've got theta on 2. What's my new domain? 0 less than or equal to theta on 2 less than or equal to 1 pi. In other words, I'm only interested from 0 to pi or 0 to 180 degrees. That's why I'm only getting one solution. So therefore, theta on 2, what's that angle? Acute angle theta on 2. So I'm going to go that it's basically, it's 30 degrees, pi on 6. Yes, so it's theta on 2, so therefore it's quadrant 1 only because quadrant 3 is excluded, it's outside the domain, as quadrant 3 is outside the domain for theta on 2. So therefore theta on 2 is pi on 6, therefore theta is 2 pi on 6, which is pi on 3, which was the solution that we got before. Okay, now second example, we're going to solve this equation sin x minus root 3 cos x equals -1. Notice it's of the type a sin x plus b cos x equals c, or the other way around. So we're being asked to put it into that format first, and then we're going to solve that equation. Let's use auxiliary angle method first. So this is method 1. All right, you know what to do? Sin x equals minus root 3 cos x equals r sine x minus alpha. You expand it. R. What's the expansion? You can do the. I don't want you taking the shortcut method of b over a. So it's r sine x cos alpha minus r cos x sine alpha. Guys, it's only one expansion that you need to write. You don't have to rearrange these. Now, if you want, you can just go to the next step. There's the sine x, so therefore, r cos alpha is, and r sine alpha. So there's your cos x that matches up with that cos x. That sine x matches with that. R sine alpha is? No, it's actually just root 3 because the minuses are the same. The root 3's. You okay? It's not negative root 3 because this minus is the same as this minus. The cos x is the same, therefore r sine alpha is root 3. Yes, rearranging them, we know we're going to get same value. We know we're going to get 2, okay? The right angle triangle, yes, we know that r is 2. We know that theta's alpha is 60, all right? No. So, see how the first term has sine x? This one has sine x. Therefore, r cos alpha is 1. See how this is cos x and that is cos x? Therefore, r sine alpha is root 3. You're comparing left-hand side and right-hand side. When you do the expansion, sometimes it's easier just to then, next step, just swap these two around, swap those two around. Minus r sine alpha cos x. Now, I'm going to underline the sine x and the cos x here. So, if I'm comparing the first terms on left and right-hand side, can you see that the sine x's are the same, and there's a 1 in front of this sine x, therefore r cos alpha is 1. If you look at this side, the minus is the same. You've got root 3 in front of cos x. What do I have in front of cos x? R sine alpha. The minuses are the same, so the r is not negative. Do you see that minus minus? You're just saying if this side equals that, r cos alpha has to be 1 and r sin alpha has to be root 3. Yeah? Yeah, you compare the left and the right hand side. So sometimes it's easier just to swap those two. Swap those. See how I've swapped them on the next line? Then it's easier to see. All right. So now r is the square root of 1 squared plus root 3 squared, which is 2. Square root of 4, which is 2. And tan of alpha is root 3 over 1. In other words, alpha is pi on 3. Is that right? 60.
Mm-hmm.
Sine x minus root 3 cos x equals r sine x minus, oh, so what's the r again? 2 sine x minus pi on 3, which is 60. All right, so let's keep going. So now we're going to solve. So now we want to solve sine x minus root 3 cos x equals negative 1. Do you know what to do? We replace the left-hand side with 2 sine x minus pi on 3 is negative 1. What do we do? We divide by 2. Sine of x minus pi on 3 is negative a half. Okay, a few things we need to do. Remember, there's always 3 steps, or 4 actually. We're going to have to change the domain. The domain is not just x. So this is for 0 less than or equal to x less than or equal to 2 pi. I don't have that. I've got x minus pi on 3. So what's my new domain? Well, we're taking away pi on 3 from each. 2 minus a third, 1 and 2/3. All right, what else do we do? What does the negative mean? Quadrants. Cos is negative. Quadrants 3 and 4. Oh. Okay, got a bit of a problem here. Oh, no, we don't. It's all good. Beautiful. Okay, quadrants 3 and 4. Acute angle. X minus pi on 3. Sine of that, ignore the negative. The negative just tells me the quadrants. Never put the negative in. But it's an exact value anyway. Sine of what is a half? Sine of 30. This has to be 30, which is pi on 6. So the acute angle for that is pi on 6. That's the acute angle. We know the answer is not 30 because 30 is in quadrant 1. So I've got to come back to quadrants 3 and 4. So I draw my little thing, quadrant 3, quadrant 4, pi on 6, pi on 6. Right, minus a third pi, that's bigger. Here's your, where's 5 pi and 3? It's about, I think it fits in. Because isn't 1/6 smaller than a third? All right, it fits. All right, so what are my answers for quadrant 3 and 4? So therefore, x minus pi on 3 is, quadrant 3 answer, what is it? Good. And quadrant 4 answer, yeah, it's 2 minus 1/6, 2 pi minus, 11 pi on 6. Is that too big? No, one. Is it too big? Is that bigger than 1 and 2/3? It is. Cross this one out, can't do that, it's too big. So we've got to go negative. Negative pi on 6, yes, sorry, that's smaller. 1/6 is smaller than a third, yeah. So yeah, sorry, see how I got the red line there? I went over it. So that one's out. 1 and 5/6 is bigger than 1 and 2/3, isn't it? So you're only allowed to go up to 1 and 2/3. 1 and 5/6, we know 5/6 is bigger than 2/3, all right? Yes, it's more of the cake. So therefore, we cross that solution out. We've only got these two solutions. So now to do my answer, I add pi on 3 to both of those. And you would get, well, double this, you get 9 pi on 6, which is what, 3 pi on 2? And what's that say? Minus pi on 6. That's a 2. Do you get pi on 6? Yeah. Negative 1/6 plus a third is pi on 6. Next thing, we're going to solve sin x minus root 3 cos x equals -1 using t formula. So using the t formula, sin x minus root 3 cos x is -1. I've got 2t over 1 plus t squared minus root 3 times 1 minus t squared over 1 plus t squared is -1. Just being very careful here, I'm actually going to write this with a single denominator. 1 plus t squared on the denominator is -1, but I'm going to write this as a single numerator. So 2t minus root 3, 1 minus t squared is -1. Now I'm going to multiply both sides by 1 plus t squared, and I've got 2t minus root 3, bracket 1 minus t squared is negative, bracket 1 plus t squared. So now this becomes 2t minus root 3 plus root 3t squared. Remember to use the brackets here, -1 minus t squared. I'm going to take everything over to the left because that would make t squared positive. Root 3t squared, I'm going to do the t squareds first, plus t squared. Then I've got plus 2t minus root 3 plus 1 equals 0. Now taking out t squared as a common factor, t squared bracket root 3 plus 1 plus 2t. I'm going to write my constant as 1 minus root 3 because I don't like having the negative at the front, is 0. Okay, now to solve this equation, it is a quadratic equation. So your a is root 3 plus 1, your b is 2, and your c is 1 minus root 3. So let's solve for t. So t equals -b, which is -2 plus or minus the square root of b squared, which is 4, minus 4 times root 3 plus 1 times, or 1 plus root 3, you could write that as, times 1 minus root 3 over 2 bracket root 3 plus 1, which is -2 plus or minus the square root of 4 minus 4 times, now this is 1 plus root 3, 1 minus root 3, which is a difference of 2 squares. So I can just go over here, 1 plus root 3 times 1 minus root 3. That's a squared, which is 1 squared, which is 1, minus b squared, which is root 3 squared is 3. So 1 minus 3 is -2, so that becomes -2 there. Or if you go root 3 minus root 3 plus 1, sorry, we got root 3 minus 3, sorry, plus 1 minus root 3. You end up with -2 over 2 bracket root 3 plus 1. So this becomes -2 plus or minus the square root of 4 plus 8 is the square root of 12. So it's the square root of 12, which is root 4 times root 3, which is 2 root 3. So it's over 2 root 3 over 2 bracket root 3 plus 1. The reason I did not expand this before is I was hoping that I would have an even number here so that I could cancel out. So you can divide the numerator and the denominator both by 2 and you get -1 plus or minus root 3 over root 3 plus 1. So now that is, so I need to separate this as two fractions. It's -1 plus root 3 over root 3 plus 1, or -1 minus root 3 over root 3 plus 1. Now this second one is actually -1 plus root 3. Now remember, root 3 plus 1 is also 1 plus root 3. So the numerator here is the negative of the denominator. So these end up cancelling and you get -1. So we're trying to solve two things here. We've got root 3 minus 1. Basically what we've got here is t is root 3 minus 1 over root 3 plus 1, or t is -1. So we're solving those two. So the t is -1. Remember, t is tan theta on 2. Tan theta on 2 is -1. Now this t is -1. This is not sine or cos, so we don't sketch the curve. We need to look in our quadrants. Remember, we've got to change domain. So 0 less than or equal to, sorry, I should be putting x here, so it's x. So 0 less than or equal to x less than or equal to 2 pi will give me 0 less than or equal to x on 2 less than or equal to pi. So we're only interested in quadrants 1 and 2. Tan is negative in quadrant 2, so this is quad 2 only. Now you need to see whether this expression will be positive or negative. Root 3 minus 1 is positive. Root 3 plus 1 is positive. A positive divided by a positive is a positive. So this is quadrant 1 only, not quadrants 1 and 3, because our domain only goes up to pi, which is 180 degrees. So now x on 2, tan of what is 1? It's tan of 45. So acute angle x on 2 is 45 degrees, which is pi on 4. So remember, we're trying to do quadrant 2. So therefore, x on 2, quadrant 2 is 180 minus, or pi minus. I can draw it, pi on 4. If that's pi on 4, then that's 3 pi on 4. So it's 3 pi on 4 is what x on 2 is. So therefore, x is multiplying by 2 on the other side. You get 6 pi on 4, which is 3 pi on 2, and we know that that was our solution when we did this question before. Now for the next one here, on our calculators, we can just put this into our calculator. The other thing we could do is, if we rationalize the denominator, we may end up with something nice and simple there. Look, you don't have to do this, but I'm going to try it over here. So root 3 minus 1 over root 3 plus 1, if I rationalize that and multiply by root 3 minus 1 over root 3 minus 1, what do I get? I get root 3 minus 1 squared. I don't think I'm actually going to end up with anything. Well, I might end up with something nice. We'll see. I end up with root 3 squared, which is 3 minus, remember, this is a perfect square. Root 3 minus 1 all squared is root 3 minus 2 root 3 plus 1 over, and this is the difference of 2 squares, which is 3 minus 1. No need to really do this. So it's 4 minus 2 root 3 over 2, which is 2 minus 2 root 3. I mean, you can rearrange this into this format. It might be easier to put in your calculator, but there's no need to. So x on 2 is tan to the minus 1 of this, and whatever answer you're going to get, that's your answer, because it's quadrant 1 only. Now what I would do to be able to do shift tan of this, I'd actually work out what that is as a decimal first, keep it in my calculator. So I'm going to go root 3 minus 1 equals, that works out my numerator, divided by bracket root 3 plus 1. And I get an answer that it's 0.2679, so I do shift tan of that. And I get 15 degrees. So therefore x is 30 degrees, and let's change that to radians, which is pi on 6. And they're the same solutions as what we got before. Now there is one other thing that you're supposed to check for with t method, that that 180 degrees or pi is not a solution. So I'm going to cut at the end of the question, you need to check that x equals pi is not a solution, because sometimes it is. So this is for t formula. You must always do this check. So let's see, we've got, here's my question, sine x minus root 3 cos x is negative 1. So let's check that x is pi is not a solution. Sine pi minus root 3 cos pi, let's see what it equals. That's sine of pi, if I just do a quick sine sketch, sine of pi is 0, so I get 0 minus cos of pi is negative 1. So 0 minus root 3 times negative 1, well, that's positive root 3. That does not equal negative 1, therefore pi, x equals pi, is not a solution. Okay? All right. That's the end of that question. So don't forget to do that check when you're using t formula, that x is 180 degrees or x is pi is not a solution. Now, the time that it will be a solution, see how I've got t squared here? If in doing this t formula, when you're working out using the t formula method, if you lose the t squared somewhere along and just end up with a linear function, then often t will be a solution then. Okay?